So we're at investments, business 3502. This is chapter 4, question number 5. Pardon me for that. This question gives us information on holding period returns and asks for calculations of mean. So we're asked for the mean of scenarios and then standard deviation. Okay. So let's go to full screen. I've written out where we start, the information that we're given. Our purchase price is 100, treasury bill price is 4%. Probabilities in a boom economy 0.35, in a normal economy probability of 0.30 and a price 110. Recession 35% probability and price drops to 80. We're also given in our table on page 117 holding period returns. Not 117, in our question on page 143. Ending price and holding period returns. So if we buy at 140, if we buy at 100, sell at 140, that doesn't really give us a 44% return. Something's missing. So there is actually a dividend that we have to derive here. And in order to get 44%, we need a dividend in each case of $4. So then that works. So a loss of 20 offset by 4 positive for the dividend. So in order to have 144, we need to have the 4% dividend there. Okay, so we can go from this then and calculate our mean returns for this. So let's add a column, deviations from the mean. Or rather, to find the mean and then find our deviations. So our expected return is, we'll do that down. Expected return is probability times outcome. So starting with 0.35 times 0.44 is 0.154. Zero 0.30 times 0.14, 0.30 times 0.14 is 0.42%, and then 0.35 times 0.16, but converted to negative, minus 0.056. The sum of this then is our expected return across all these probabilities. So leaving that in our calculator, 0.5 minus 0.056, add 0.042 and add 0.154 gives us an expected return of 14%. So expected return on our portfolio. Fine. So the sum of the holding period returns give us expected return of 14% across all probabilities. Okay, Now, our deviations from expected return. We have a 44% return under a boom. So 0.44 minus 0.14 is 0.30. 0.14 minus 0.14 is a 0% return, and 0.16 negative minus 0.14 is minus 0.30 deviation from the mean. Okay? Now, to get rid of minus signs and bring us to standard deviation, we square deviations. I'll leave this in the computer. Minus 0.300 squared is 0.09. 0 squared still gives us 0, and 0.3 squared gives us 0.09. That's our squared deviations. The sum of our next step is then probability times squared deviations. So 0.35 times 0.09, 0.3 times 0, and 0.35 times 0.09. Is 0.0315, 0, and again 0.0315. The sum of those is 0.063. Our probabilities times squared deviations. So this comes down to the other part of our chart. And now the square root of this, because this represents the variance, then the square root of this, actually that's not quite true. All of this represents variance. Square root of that, 0.2510 or 25.1%. And on the safe side, checking for our textbook, we have textbook answers. The expected return 0.14 or 14%, and variance given as 630, and then standard deviation 25.10%. So it works. So that's answering methodical way to answer question 5 from chapter 14.